Well, that was pretty fun. We did set off the smoke detectors, and a really good example of lithium chloride. The minute that I put it in that water, and of course you had to be here to see it, but the minute I put it in that water I had a major reaction because lithium and potassium and all these other things really react. Lithium's extremely reactive, and boy, when I put it in that water, psst, and it just set off all the smoke alarms. So we had to go take care of those, and we're back. I did want to take this strontium chloride and this lithium chloride and show you the difference, because in strontium chloride we have red, and in lithium chloride we have red and blue. Okay, so I'm going to come back in here. Okay, I'm going to come back. Hopefully we won't set off the smoke alarms again. Okay, but I have to tell you, that's not my first time to set off the smoke alarm, so no panic there. We're doing good. So this is, let's take another look. Now, once again, the way we can really tell this as a chemist is to look through it with a spectroscope, and then that's on the sides of the wall of the spectroscope will tell us the exact colors. But once again, we can tell as a chemist when we look at a color being burned what's in it. Okay. All right. So this once again is strontium chloride. Okay. Now we get down to the yellow, which means we burn it all off. There's still a little bit more on there. Okay. So once again, one more time for strontium chloride. Now it is just red. Okay. Now it's interesting because red and blue makes magenta, and magenta is a really important color for chemistry. Red is not a bright red. It's not a maroon, and it's not a magenta. Okay. Red is a really red is not a dark red at all. It's just a almost. It's just a faint. See, that's red. See, it almost looks like a combination of red and yellow, but when I look in the spectroscope, it's just red. Okay, and once again, now why is it turning yellow at the end? Because remember now you can still see a little of it burning off. See that red? See if we got a little bit that's spilt over here. There's a little bit right there. Okay. So, but remember the color. There's some red still in there. Okay. But remember, once it's all burned off, just the nichrome loop, the bacteriological loop, and the water is going to burn yellow. So we can still see a little bit of red still on there. Okay. Now we're not going to burn this too long because we did set off the smoke alarm here a while ago. Okay. We did set off the smoke alarm. So we are going to use the lithium chloride, extremely reactive. Okay. We're going to burn it again. And remember that the lithium chloride is red and blue, which makes magenta. Okay, magenta, once again, very, very important. Oh, I've got a bunch on here. Wouldn't you know it? Golly, I know. This is a part of me really wants to see a bunch on there, and a part of me really says, aha. Okay, so I've got my safety goggles on. Now I'm going to show you another deal. I'm actually not going to sit down while I work on this because then I'm at eye level. Okay. So when I sit down, like later on when we do glass, I won't sit down because then things pop out at glass at eye level. So I'm going to move this up a little bit. Okay, I'm going to move over a little so you can see it on the black background, and we're going to look. Now that's magenta. That's see that color? That's red and blue. I just want you to see it. That's really the good color. That's magenta. See, the red and the blue makes magenta. It's gorgeous. Now that's what they put in fireworks to make them red. See how isn't that a gorgeous color? That's my favorite color. And it's really burning off, really reactive, gorgeous color. But that's not red, that's magenta. Now once again, I've got a bunch of smoke. Okay, we're going to try not to set off our smoke alarms. Okay, all right. So let's see if there's any left over on there. Okay, yep. See, even after washing it off. Okay. So once again, that is the lithium chloride that makes the magenta color. Okay, well, we didn't get carried away, but we got a pretty good chunk in there, so it was wonderful. Okay, so this is what we always do, let's go through and take another look. Let me give to you, especially since you don't have your spectroscopes. Okay, let me give to you what we had, and I'm going to give you, you're going to have a quiz on these. It's just real simply going to be what colors of the spectrum are emitted when the chemicals are burned in a flame. Calcium chloride, okay, calcium chloride, yellow, green, and violet, okay, calcium chloride, yellow, green, and violet. Lithium chloride, red and blue, which makes magenta. See, magenta is not one of the Roy G. Biv colors, red, orange, yellow, green, blue, indigo, and violet, but red and blue makes magenta. So lithium chloride, we don't say magenta because that's not one of the natural colors. Lithium chloride is red and blue. Strontium chloride is just red. Strontium chloride is just red. And then potassium chloride is green and blue, which makes it look yellow, all right? And then sodium chloride is yellow, blue, and green, okay? Yellow, blue, and green. So what I'm going to do now, okay, what I'm going to do now so that you can't guess, as a chemist we do a lot of unknowns, okay? As a chemist we do a lot of unknowns. So I'm going to come in with some of these, and I'm going to now this is like the shell game, like at a ball game where they go. So I don't want you to try to guess which ones were which, but I'm going to put a couple. I'm going to put a couple of different ones in, and let's wet this down really good. I've got one sample here. Okay, so I am going to come in here, and I'm going to get two. I'm going to get two different ones, and we're going to try to figure out which chemicals are in this unknown solution. Okay, so you have the list of colors. So this is what chemists do. Okay, this is what chemists do. They try to figure out what the unknown is. All right, so a big part of chemistry is unknowns. So now let's come in and let's burn this, and let's see what colors we see, and then let's go to our map here and see what we have. Okay, everybody ready? Here we go. So watch closely. Wow, what are we seeing? We're seeing some red. All right, we're seeing some red. We're seeing a little bit of, we saw some yellow. Okay, let me do it one more time here. Let's look at it again. Same chemicals that we did earlier here. Okay. Okay. So we're seeing red. We're seeing red. Let's see what colors we see here again. There's some red. What else do we see? There's definitely some yellow. Oh, we see just a little bit of green. I don't know if you can see it in the middle there, but green is hard to see. It's not like a bright green. It's not like a Green Bay Packer green or something. It's sure not an Oregon green that's a real bright green. But what we actually saw there, and I don't know if you can, there we go, we see just a little green. It's a faint green. It's almost an olive green. But what we see there is red, yellow, blue, and green. Red, yellow, blue, and green. Red, yellow, blue, and green. Okay, and let's see if we can see any more on there. Okay, so I'm going to, okay, so basically, all right, and I helped us out a little bit knowing what we're looking for. If you had the spectroscope, there would be absolutely no doubt in your mind exactly what you saw, and you would see red, yellow, blue, and green. So let's look at this. If we had red, yellow, blue, and green, okay, then what's our combinations? All right. Well, could it be calcium chloride? Okay. And so we have red, yellow, blue, and green. Well, in calcium chloride we have violet. We didn't see any violet, so we can rule that out. Lithium chloride is red and blue, so that's a possibility. Okay. Strontium is red. We definitely had some strontium in there. Okay. Now, how do I know that it wasn't lithium chloride? It wasn't lithium chloride because I didn't see what color. Deep magenta. There's no mistake in lithium chloride. That's what you're going to put in fireworks to get red. Lithium chloride is a magenta red, a bright red. And so, but then we did have some strontium in there, the red. Okay. Now, did we have potassium chloride, which is green and blue? And the answer is, it's possible. Okay, it's possible. And then how about sodium chloride, where we had yellow, blue, and green? And the answer actually was we had the unknown was strontium chloride and sodium chloride. and we had red, and then the yellow, blue, and green came from the sodium chloride. So in your lab, you could put that it was a possibility of those three, and then you could put which ones you think. The reason why I knew that it wasn't potassium chloride is because I didn't have the deeper green that I found in the potassium chloride. I knew that in the sodium chloride, the green was very faint, that I could barely see it. And as a chemist, as a period of time, you learn these things. When you see the very faint green, sodium chloride has yellow, blue, and green. So once again, not easy. We don't expect you to become an expert on this. We just want you to understand how it works. Now, the last thing I want to tell you here is, as I fill this can, okay, and as I turn this flame off, I have to tell you, and I wish you were here to feel it. Oh, it feels wonderful, but the can is really cold. This can is super cold. All right, it just on a hot day, it feels like an ice pack. Why is that? Because energy can't be created or destroyed. But there's something else about hot and cold, okay? There's no such thing as cold. And they're like, sure there is. No, in science there's not. Cold is the absence of heat, okay? So in your refrigerator, you don't make cold, you take the heat out. That's what the Freon does. It takes the heat and removes the heat out of your refrigerator. What does your car do? Your car removes the heat from a little chamber and then blows that air out that doesn't have the heat. Well, energy can't be created or destroyed. If we took this and made heat, then what do? We took the heat out of the gas and out of the solution. So if we take the heat, the absence of heat is what? Cold. So this is actually, and it's still really cold, and it will remain cold for a long time until the molecules are able to speed up and it's able to absorb enough heat from the atmosphere to get back up to where it was. So it's really interesting. Why is this cold? Because it has the absence of heat. Where did the heat go? The heat, when we made the heat, we can't make anything. There's no new matter. Everything is a combination of the matter and the energy we already have. It just changed in form. So this gas, as it broke bonds, made heat, but the absence of heat made this cold. So, pretty good experiment, and that's the flame test. Another good way for chemists to be able to identify by colors different chemical elements. So, what we're going to have you do is we're going to have a real simple test for you. I'm going to give you the combination of the elements, the calcium chloride, and you're going to tell me what colors it was. And it was yellow, green, and violet. Lithium chloride was red and blue. Strontium chloride was red. Potassium chloride is green and blue. And sodium chloride is yellow, blue, and green. And these are all standard ones. And then I'm going to give you a known color, and you're going to tell me what possibilities it could have been. So just a quick little quiz on this. And once again, you're learning more skills of being a chemist. See you back in the class.